find the image of the point 1, 6, 3 in the line x upon 1 is equal to y minus 1 upon 2 is equal to z minus 2 upon 3. Also find the length of the perpendicular and equation of the perpendicular drawn from the point to the line. So let us consider a point P 1, 6, 3 and there is a line the line equation is given x upon 1 y minus 1 upon 2 z minus 2 upon 3. Let us consider the image of the point P with respect to the line. Say P dash alpha, beta, gamma, and let M be the perpendicular. It's foot of the perpendicular of the point 1, 6, 3 to the line. So given line x upon 1 is equal to y minus 1 upon 2 is equal to z minus 2 upon 3. So any point on the line we may consider by taking some constant. So let us equal to constant lambda, where lambda is a constant, so that x upon 1 is equal to lambda, y minus 1 upon 2 is equal to lambda, z minus 2 upon 3 is equal to lambda. So x is equal to lambda we can write, and y minus 1 is equal to 2 lambda, y is equal to 2 lambda plus 1, and z is equal to 3 lambda plus 2. So we can say that any point on the line, on the given line, is of the form lambda 2 lambda plus 1 3 lambda plus 2. So for some time let us consider this point B. Let this point be M. Let us consider this point is M. Okay, then direction ratios of given line are 1, 2, 3, and direction ratios of the line joining P and M are, so we can consider, and here the point is 1, 6, 3 and the point is lambda 2 lambda plus 1 3 lambda plus 2, so we can write lambda minus 1, because the line joining the 2 points x1 y1 z1 x2 y2 z2 direction ratios are x2 minus x1 y2 minus y1 and z2 minus z1. So we can write lambda minus 1 and 2 lambda plus 1 minus 6, that is 2 lambda minus 5, and 3 lambda plus 2 minus 3, that is 3 lambda minus 1. So these are the direction ratios of PM. So let me write to understand here 1, 6, 3.1 and one more point lambda 2 lambda plus 1 3 lambda plus 2. Just find the differences, x2 minus x1 y2 minus y1 z2 minus z1 are the direction ratios. Okay, and since the line joining P and P dash is perpendicular to the given line, and hence we can say the dot product of the direction ratios is 0. Since PM is perpendicular to line, so that we can write So 1 times of lambda minus 1 plus 2 times of 2 lambda minus 5 plus 3 times of 3 lambda minus 1 is equal to 0. Since two lines are perpendicular, the dot product is 0. So which implies that lambda minus 1 plus 4 lambda minus 10 plus 9 lambda minus 3 is equal to 0. So which implies 9 plus 4 13, 13 plus 1 14 times lambda, and minus 14 is equal to 0, or we can say lambda is equal to 1. If lambda is equal to 1, hence the point M, that is foot of the perpendicular, we can write foot of perpendicular of point P 1, 6, 3 with respect to the given line is M. So substituting lambda is equal to 1 in the point, so we can write 1, 2 into 1 plus 1, that is 3, 3 into 1 plus 2, 5. So 1, 3, 5. So 1, 3, 5 is the foot of the perpendicular, and since M is the midpoint of P and P dash, M is the midpoint of P and P dash, so therefore we can write alpha plus 1 upon 2, beta plus 6 upon 2, gamma plus 3 upon 2, which is equal to 1, 3, 5. So which implies that alpha plus 1 upon 2 is equal to 1, beta plus 6 upon 2 is equal to 3, gamma plus 3 upon 2 is equal to 5. So which can also be written alpha plus 1 is equal to 2, beta plus 6 is equal to 6, and gamma plus 3 is equal to 10. That is alpha is equal to 2 minus 1, 1, beta is equal to 0, and gamma is equal to 10 minus 3, that is 7. Therefore, image of point P with respect to the given line is 1, 0, 7. So that is P dash. So image we got it, and foot of the perpendicular we got, and the distance, also find the length of the perpendicular. So the length of the perpendicular is distance between P to M. Length of perpendicular is equal to the distance between the P and M, so which is under root of point P is 1, 6, 3 and M is the point 1, 3, 5. So 1 minus 1 whole square plus 6 minus 3 whole square plus 3 minus 5 whole square, so which is equal to under root of 0 plus 6 minus 3 whole square is 9 and 3 minus 5 whole square is 4. So we can say the length of perpendicular is root 13. Root 13 is the length of the perpendicular. And also now we need to find the equation of the perpendicular drawn from the point to the line. So let us consider the equation of a line joining these 2 points P and M. So we can write it as equation of a line joining P 1, 6, 3 and M 1, 3, 5. So we can write here since we know that x minus x1 upon x2 minus x1 is equal to y minus y1 by y2 minus y1 or z minus z1 by, so z minus z1 we can write it as z2 minus z1. So we can write here x minus 1 divided by 1 minus 1 0, and we can add y minus 6 upon 3 minus 6, which is equal to z minus 3 upon 5 minus 3. Say here 1 minus 1. So the line equation is x minus 1 upon 0 is equal to y minus 6 upon negative 3 is equal to z minus 3 upon 2. Or we can also write x minus 1 upon 0 is equal to 6 minus y upon 3 is equal to z minus 3 upon 2. So this is the required equation of the line. And hence equation of the perpendicular we got image of the point, length of the perpendicular, and also we found foot of the perpendicular. Okay.